card to all this. In fact, there's two wild cards to all this. The first one here is Mars. We have some really interesting space weather that has been sent off to Mars. It is a critical piece of this planetary alignment. And I think we're going to see some very interesting plasma and or electromagnetic effects unfold as a result of this that could shake things up even more. We have just a weak coronal hole here, but very large in the southern hemisphere. So we have just a lot of the Earth facing side of the sun right now dominated by coronal holes, which are well linked to high magnitude earthquake activity, global seismic bursts, and more. That is the first thing. This sunspot there also being pretty significant, but there's more than just that. Let's look at what just happened on the sun. We will see that here with our 304 angstrom view for the past 24 hours. And you will notice a really significant coronal mass ejection launch off here. We also see some interesting plasma stuff down there. But you'll see this one go off like this. So this is going to happen any moment now. I'll see this large coronal mass ejection expand off. And this will be in the direction of Mars. So that's quite significant. There it is right there. See that? That's a big coronal mass ejection. It's not exactly from the limb. It's also not exactly opposite the Earth. Mars is right now roughly at that 45-degree angle in between those two. And as you can see, that's going off that direction. So we have a coronal mass ejection going to Mars, and that impact is expected on the 19th around 2:30 a.m. Universal Time. There was already a coronal mass ejection that launched to Mars about 18 hours ago. I can show you that one right here. So here we see the big explosion on the sun's far side from the 13th that launched out towards Mars as well. So now we have one going to the north of the ecliptic plane, but still along it. This one going to the south of the ecliptic plane beforehand, both of these off to the red planet. That is quite significant. And we can see the most recent one again here. I have it very nicely shown there, going out. So the expected impact to Mars for that is on the 17th at 1800 Universal Time, and then on the 19th at around 2:30 a.m. Universal Time. Let's check out the NASA space weather models because that gives us a further clue into some really interesting space weather dynamics and how this space weather impacting Mars could trigger this planetary alignment in a very unique way. Here we see the NASA space weather model for this far side event that occurred right here on the 13th, okay? And we see this coronal mass ejection go out. This is the planet Mars. We see Earth right there, a whole bunch of other things that they track. You can see it all up there. But this is going off to Mars. We see it very clearly going there, and estimated impact again 1800 Universal Time. So that is hitting. We see the other space weather model from NOAA for the second far side eruption. Again, this one there, a bit more to the north. Not as large, I would say, but still quite significant as we see basically perfect direct shot to the red planet. So we have two big interplanetary coronal mass ejections that will be sweeping by Mars back to back right as this planetary alignment that involves Mars goes exact, effectively. Okay, well, let's talk a little bit more about why that's important. Here we see a screenshot from that first model, okay? And that second coronal mass ejection, though it's not pictured here, would be following up right behind. We're not going to be speaking about electromagnetism because while these planetary alignments do involve gravity, and that's a very important component, we can extend beyond just a gravity-only understanding to electromagnetic reality as well. And that's the dominant force in the universe as far as we know. Much stronger than gravity is. Here we see a co-rotating interaction region right there. So basically this is plasma density. Here we see another co-rotating interaction region, plasma density. You see that overall the solar wind has a structure to it. It's not homogeneous. You have low density, high density, low density, high density. In the magnetic field, there's this clear differentiation between different zones within the solar wind that are primarily delineated by these co-rotating interaction regions. Well, here we have Mars, and we have this one going out like this co-rotating interaction region, this one as well, this CIR, C-I-R. We have this coronal mass ejection right there connecting the two together. So you have this now higher density structure extending deep out into space to the red planet that connects directly back to the sun. That's really interesting. It basically shows that there can be a flow of energy through this. When we're talking about plasma, when we're talking about space weather, all this stuff, fundamentally we're talking about circuits. And what we see here is a very nice example of an interplanetary plasma circuit. And what's so interesting about circuits is that they have this electric current that runs through them. And they can also release explosively at times. That's what we see with the big solar flares, that there's a little circuit close to the sun that gets disrupted that causes this big release of energy. It's all in there latently, and then it just explodes. So we have this circuit, this flow of energy, and this flow of energy is going to be passing through the red planet. Now in space, you don't have that much resistance. If it's all, if this plasma feature, for example, is going out, there's nothing really in the way. Well, Mars is a big planet, and it doesn't really have much of an atmosphere. It's not really conductive. Earth has an ionosphere, so it's conductive. Venus has a really strong, rich electric ionosphere, so it can take part in all these things. Mars is just kind of like a dead red rock in the way, like a big resistor. Well, how do you think that's going to affect the circuit? That's the big unknown, but it's going to disrupt that circuit. The question also is, how significant is that disruption?